Hi, my name is David Wakerley. I'm the co-founder and CTO of Dioxycle, and I currently am quietly optimistic about the future. It's very easy right now to be pessimistic about the state of the environment and our climate. It's very easy to see all of the problems we're currently facing with global supply chains for things like oil and gas, and the amount of carbon emissions we produce every year continues to grow. But I am optimistic that the technologies we need to fight these problems are being developed, they are out there, they are possible, and I'm optimistic that we can use these technologies to overcome this 21st century problem, which is climate change and global warming.
Future Optimist.
Techno-Optimist.
I'm very optimistic about the technology that we're building at Dioxycle. I'm the CTO. That kind of comes with the job title, but
you kind of have to be.
Exactly. Yeah. If I was like,
or else you're out. You're out
pretty
of a job.
much. I don't think I would want a job where I wasn't very optimistic about the potential of the technology. Let's put it that way.
Yeah.
And what we're building is a solution to one of industry's most polluting, environmentally disastrous processes, which is the production of a chemical called ethylene. I will obviously, I can go into that for about half an hour, so I'll let you ask all of your podcast questions before I bore your audience.
We're going to get into that, yeah. I just wanted to point out that here in the United States, ethylene is now the most popular girl's name in 2024. Hey, Ethylene, come on over here. Get back in the trailer, Ethylene. Not really.
No, I
figured that out.
I figured that was a joke. It's
like I can hear the tumbleweed rolling through the studio.
I can segue with that. Okay. I mean, ethylene is everywhere. It's rarely.
It's ubiquitous. Thanks for saving me a little bit.
Not so much as
letting me escape with some piece of my dignity.
No, the impression was phenomenal. But the ethylene in general is as part of the American life as spurious little girls' names in the Southwest, which I think is what you're alluding to. It is really in every product around you right now. For example, if you look around the room, there is maybe
got to be surrounded by it.
Things that have touched the ethylene supply chain, every plastic, every piece of PVC, all of the electronics, or anything that's not metal, wood, or edible is gonna in some way, shape, or form be involved with the production of ethylene.
Yeah. And obviously, this is traditionally a byproduct of fossil fuels, or at the very least, the petroleum industry. And it's not very sustainable, not very recyclable. It's something that exists as part of squeezing every ounce out of a barrel of oil. But there's got to be a better way if we channel our inner infomercial host. What is it that you see in the production of ethylene? What is the process, and how did you stumble upon
the process right now? Is we take a barrel of oil and 90% of that goes towards making jet fuel, diesel, gasoline, all the things we need to get from A to B. The other 10% then is the leftover part that's not useful as a transportation fuel. We basically heat that up like you wouldn't believe in a big chimney, essentially, called a steam cracker. And that steam cracker is fed methane, it's fed steam, but it's powered by methane gas. It's used to methane, this is America. Fed by methane, and that basically cracks down this last fraction of the oil barrel and produces ethylene. And from that ethylene, you can grow just so many different chemical products that I just alluded to. The problem is, for every ton of ethylene you make 1.5 tons of CO2. And not only that, the ethylene that you produce, this carbon that you produce that goes into all of these different products, it's come from oil. So when that product, either your plastic bottle or your textiles or PVC, when that eventually breaks down, that will also release CO2 into the environment that came from a fossil source. So some estimates say right now that about 250 million tons of CO2 were released every year in the production of ethylene. But there are some new estimates coming out saying the ethylene and the plastics industry in general could be accounting for about 5% of our global emissions. So similar levels of emissions to the steel and cement industries, which are known for being the dirtiest, most carbon emitting industries on the planet. So basically, it's a chemical that we need. We will always need medical implants. We'll always need plastic bottles for holding certain liquids. Obviously not, we don't want plastic to be ubiquitous, but we always need it in some regards because it is the best way of holding liquids or packaging containers in an inert way. We'll always need things like PVC flooring. We need these parts of our society to be continuously produced for us to make more houses for people, for us to make more cars for people, everything we need just to continue living the way we do. But we need to stop making our ethylene from fossil fuels. And that's what our company does. We have made an electrolyzer that can take carbon emissions. So no longer a fossil source of carbon, but carbon emissions either from industrial site that is heavily emitting or from a biogenic source of carbon from things like, you can do things like just take carbon from some other, I won't go into it, but processes that use bugs and microbes, or you can directly capture carbon from the air. It's called direct air capture. I think you probably came across it in your podcast before. And we take those carbon emissions and convert those
I have
into
actually
ethylene.
once. Yep.
Great.
Once or
Yes.
twice.
Exactly. Well, it's the
Yeah.
complementary technology to what we do.
You know,
we take those and we convert them into ethylene.
You know, it's funny, in a previous life, I've been called a steam cracker before by certain communities. I think it's due to my complexion and the fact that I talk so much. Also, in college, fun fact for the listeners out there, my DJ name was DJ Electrolyzer. That was many years ago, though. I used to enjoy playing that kind of music. But it's a lose-lose proposition. You're polluting at the source, you're polluting later, you've got all this waste that's going to the earth, and if it eventually breaks down, which takes thousands of years, if at all, it's going to pollute again. Lose-lose, even though it is very convenient for all of the stuff that we need. What you're describing is what I love most, which is a win-win or a win-win-win, where you are taking a positive version of this. You're reducing waste, one of the R's that we are all taught as school children. You're reducing the waste that's coming out of these factories and these industrial processes. You're using it in combination with renewable energy to create something that could replace many of these products. And you're right, I have talked about this before on the podcast. I spoke with Mark Harima of New Light Technologies, who's making something called air carbon, and they're making plastic utensils and items out of carbon capture. I've spoken with somebody who captures heat from industrial processes. His name is Martin Schichtel from Kraftblock. And that's also very fascinating because there's a lot of heat waste that comes from these processes. But I don't think anybody I've talked to is quite doing what you're up to. And that's why I'm so fascinated to talk with you today. What percentage of products, all these things around us, could theoretically be replaced with this more sustainable solution?
Oh, wow. Interesting question. I won't give you an exact number, but it's high. What I can do is tell you everything ethylene is
That's
converted
amazing.
into, and that will give you an idea. So, and this is going to be a long monologue. I apologize, but you take
I'll get some popcorn.
Exactly. Ethylene to PVC is one of the largest uses of ethylene right now. So PVC is window frames, plastic piping for your guttering. It is the flooring that you have. It's a number of other applications too in a lot of different products you use. Ethylene to polyethylene is every plastic bottle, every HDPE bottle, LLDPE bottle, LDPE bottle. There's a huge number of different containers, different furniture, different furnishings, medical devices which use polyethylene. And the other thing you can do is make ethylene oxide, which is converted into ethylene glycols. That's every adhesive, glue, cream. I can continue. I won't. All these different, more gooey, let's say, to put it in very vulgar terms, very gooey.
Post-it notes.
Post-it note glue, for example. All these things will be derived from ethylene. If you go to the supermarket, you will literally see ethylene on every product you buy in some degree or another. So that's what
that makes sense. So you really think that the potential is high? Because a lot of these things, people talk about the ever expansion. It's not that we're, contrary to public opinion, we're not slowing down our production of these things. They're actually increasing. And of course, as the standard of living globally improves, what goes along with that is greater levels of consumption. And part of that consumption are these plastic products that certainly the United States is most famous for. Everything is disposable. All of these plates, forks, all just plastic is something. You go to fast food and you get a whole bag full of plastic garbage. You eat it, 2 minutes later, it's in the landfill. That's the way that we roll here in the United States. And as other people seek to emulate that, these numbers are rising. They're not only not plateauing, they're not shrinking, they're growing. right? Sometimes when I talk to people with solutions like yours, they'll say, it's a small percentage of the market that we could potentially capture, a few small percent. But you really believe that this has the potential to perhaps displace a large amount of these more harmful fossil fuel-derived plastics.
It's the same product at the end of the day. The ethylene we make is the same ethylene that would go into all these different plastic products.
Incredible.
So one thing I want to highlight, though, is
Incredible.
It's incredible, but we still want to teach sobriety. We still want people to stop using plastic utensils.
Just burn piles of Legos.
Exactly, right? I mean, number one, don't burn your Legos. They're very valuable. But secondly, we don't want people to think, oh, this means I can go get that third bottle of Mountain Dew and throw it into a landfill. We need to be recycling more. We need to cut down the amount of packaging in general on the products we buy. There's nothing wrong with washing your broccoli when it gets home. It doesn't need to be covered in film or any other foods you may want to eat. For me, the solution we provide is for all of those more essential products, less single-use plastic, more technologies, like I said, medical components, glues, different furnishings, construction. We need ethylene in our construction for that. We need the PVC. It's long lasting. It is very robust. It's bendable, so it doesn't just crack like a ceramic or a stone pipe would. There's so many advantages to a lot of uses of ethylene. We don't want to stop using them. The products we do have, we want to produce in a sustainable way, because the carbon footprint of even PVC, even the like 1 or 2 meters of PVC piping has a carbon footprint that you wouldn't believe. I can't remember the number exactly, but it was something like a trip to New York. For 30 meters of PVC piping, I think, had the same carbon footprint as one person's flight to New York from Paris.
Incredible. And we're giving Taylor Swift so much shit for flying on a private jet, when in reality, many other industries are polluting far more than that. That's an interesting take.
I will say, and this is, I'm glad you brought up Taylor Swift.
Oh, no.
It's slightly irrelevant. But I'm glad
warning.
I'm glad you brought up aviation, because the plastic industry, with the some new numbers have come out of Lawrence Berkeley National Lab, saying that the current plastic industry in 2019 was 4 times more emitting than the aviation industry. And it could end up being 10 times more emitting than the aviation industry by 2050 if we don't do something about our plastic production supply chain.
What an incredible stat. And so you've got somebody over there who's sipping on their 2-liter of Mountain Dew, judging Taylor Swift, and they're saying, you need to stop flying private. Look. And it's maybe
a
maybe
beautiful
we're all
picture.
a part of this in some degree.
A beautiful...
we're all complicit in some way or another.
Exactly.
I've got more than my fair share of plastic.
And right now, there's not much you can do about it if you are just living a regular life. If you want, there are not many supermarkets nearby that you can just go and get some low carbon footprint ethylene products. It's hard to find, and that's hopefully one area where I rephrase that. We don't want people to go to supermarkets and pick up low ethylene products. We really want supermarkets to stop using single-use plastics. But what we want to give people options for are things like, for the liquids that you need, let's say detergents, other packaged products that basically need an ethylene-based packaging. We want to provide that with our low carbon footprint ethylene rather than the fossil alternative. Let's put it that way.
Completely agree. And there are solutions out there. They're just very expensive and they're very niche. Like deodorant, there are things that you can buy that don't have plastic. And I do purchase those things where possible. But I've felt for years that it's insane that things like shampoo and all of these disposables that we use come in these giant plastic bottles. It just doesn't need to be that way. We have this incredibly valuable, incredible miracle material, really, because would modern medicine even be possible without it? I think the obvious answer is a heartfelt no. But we aren't using them in a very conscientious or responsible way. We're just burning through this very valuable, very awesome thing. We're not picking and choosing where we use it. And that's kind of the danger. And there are 2 examples that come to my mind when I think about your story. One is the National Geographic Mega Factories. They sometimes do this show called Mega Factories. They did one on Coca-Cola. And if you haven't seen the Coca-Cola Mega Factories, it's nuts. You see football fields worth of plastic 2-liter bottles belching off of this conveyor belt that is the largest conveyor belt you've ever seen in your entire life. And on the one hand, it is unbelievably impressive how much Coca-Cola they can produce in a minute and an hour. And it's truly a miracle of human achievement. And yet when I look at that, all I can see is just garbage, just spewing out. And you think, my God, that is an incredible amount of plastic garbage we're just pumping out for no reason. And it doesn't obviously have to be that way. It could still be glass bottles. It could be other vehicles, even for the same thing. And one thing that I've always thought, I used to live in Europe actually for 9 years. My wife is Dutch. I lived in the Netherlands for 9 years. So I completely like the way that they have handled certain things that America has not addressed at all. And one of those most important things is when you buy a crate of beer in the Netherlands, first of all, it's a reusable crate of 24 glass bottles. When you're done drinking the beer, you put the empty glass bottles back in the crate. You go to the grocery store, you return the crate with the empty glass bottles. They give you money back, a few euros, and then they simply rinse those bottles out, sanitize them, clean them, fill them with beer again, and sell it again. I would give anything for something like that to be widely commercially available in the United States. I just don't understand. Why can't I refill a shampoo bottle? Why can't all of our beverages be reused? And we talk about reduce, we talk about recycle. These are valuable R's, but we very, very, very little talk about reuse as a component of these things and finding better ways to reuse the stuff that we actually have.
100%. And that is, I mean, it's not my focus in particular. That's not something I'm an expert on per se, but
Sure.
I completely agree with you. We need to reuse way more than we do. And I see them all the time, these great ideas of people coming up with the supermarkets where you go and you refill, let's say you refill your cereal, it doesn't come in a box, it comes in it has one of those
Right.
hoppers that distribute cereal.
Yeah.
I think we just need more campaigns to teach people just the level of carbon footprint they have when they're using plastics. And I think I would say that recent reports have shown how carbon intense a lot of plastic producing processes are. Sorry, that's a lot of P's. And hopefully this data can be used to teach people the kind of evils of that industry in a way that is very good for people. For example, people used to fly a lot. I think people are a lot more conscious of how much they fly. Now people are aware of just how damaging it is for the environment. And we just need more people to go out there and say, listen up, that plastic you're using has as big a carbon footprint as XYZ. You have to limit that in the same way you're limiting your beef intake, the same way you're driving a Tesla.
Yeah, very, 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 very good points there. You have a PhD in chemistry from the University of Cambridge. You've done a stint at Stanford, and it appears that your latest idea came hot on the heels of leaving Stanford. Do you attribute your time at Stanford to the genesis of this new idea? Is it completely unrelated? At what point did you lock on to this as a problem that you
Great
could
question. So, number one, I will start by just giving a shout out to my co-founder. So all of my academic career I did with my co-founder, which for anyone looking to start a startup is the best test of your co-founder relationship. If you can survive academia with someone, you can survive anything.
Nice.
So her name's Sarah Lemaison. I did my PhD in chemistry on electrolysis. So your college DJ name, that was me in university. I was always looking, exactly, that was me. In the lab. We're called electrochemists, but it's way less electro than you're probably imagining. I guess when you hear electrochemist, you think Daft Punk with a test tube, but sorry, I've lost my train of thought. Yes, the PhD.
Sounds like a great
the PhD in
co-founder,
chemistry.
PhD.
Basically, I was always focused on electrolysis. Electrolysis is the one technology that can turn energy into useful chemicals. There are others out there. There are other things you can do. You see, you're approaching for a closer look. Basically, electrolysis is the one thing that lets you take renewable power, pump it into a chemical bond, and make something more useful and more energetically, with a higher energy content, I should say. So I was always fascinated with the potential of that technology to displace fossil fuels. I then, with my co-founder, we went to the Collège de France in Paris and we learned about the fundamentals of electrolysis in the realm of CO2 utilization. This is CO2 conversion into something else, because with the electrolysis technology, you could, in theory, find a way to turn CO2 back into fuel. So we did some real fundamental research there before. So I moved to Stanford after that. Actually, the full story is, after 2 years at the Collège de France, which is a really fantastic research institute in the heart of Paris, I said to my co-founder, I need to move on. I've been here for 2 years. I think I'm going to apply for Stanford. So I got this grant from the UK government that took about a year from genesis to application to receiving the grant to receive. Sorry, that's a terrible way of putting it. Took me a year to get this grant. And then I had to do the visa process and all these different things to get into Stanford. And my co-founder, who was just funded by a very relaxed and very, not relaxed, let's say, but a very open funding institute, said, "Oh, should I come to Stanford too?" And I said, "Yeah, oh, you should try."
Wow.
But bear in mind, it took me a year to get into Stanford with all the different things I had to apply for. She picked me up at the airport. She picked me up at Oakland Airport because they just said, "Oh, yeah, come along." She got the visa too. We started researching in Stanford. I was there for just over a year. COVID hit during, so it was a bit harder for us to get much work done there. But what Stanford told us about, or what Stanford taught us more than any other university I've ever been to, was how entrepreneurship works. It is just such a hotbed for new ideas. The research is, people are thinking about what their startup will be whilst they're doing their academic research. And I think that's such an incredibly engaging environment to be in when you're in academia. It's very easy to get stuck in the weeds and think to yourself, "Oh, what's the point of this research?" And in Stanford, everyone knows what the point of their research is. And they're always, not everyone, but there are so many people thinking about how that could then be turned into some form of revolutionary new technology. And that was very exciting for us to be a part of.
That's awesome. And I was just there recently, and I don't think I ever fully appreciated the energy of that area until this last trip. I was there about a month ago. I toured all around. I had some meetings and potential clients and all of this. And I really took a car and I just drove. I drove to all of these campuses. I drove around, saw the Google campus, the Meta campus. I went to Stanford and just got a sense. Steve Jobs' home in Palo Alto, I got a sense of the area for the first time, which I had never done. I'd been to San Francisco. I'd actually been on the other side, Oakland, Napa. And my brother used to live halfway in between those two areas, but I'd never really gone south through the Silicon Valley area. And with a rental car, I highly recommend anybody who's curious about these things to do that, because there is an energy that is absolutely palpable. And I wanted to get a sticker for my daughter from Stanford. So I got out of the car, I walked through the Stanford campus, and the kinds of conversations you hear, it was very energizing. And the type of thing that people are working on all around you, it's really, really special and really remarkable. And it's hard to articulate until you see it and experience it for yourself. I live now in Southern California, and if you could say there's such a thing as a rivalry between Southern California and Northern California, here it's all entertainment industry, but there it's all business and tech and possibilities. And I love the entertainment industry, many amazing things coming from this part of town, but that focus over there, it is really, truly something special. And that's why I asked about it. So do you think it was truly a catalyst for you being on this? Would you have done it if you hadn't taken that year?
So my co-founder and I, the reason we worked in so many places together for a long time, so me and Sarah always wanted to do something. We knew the research we were doing had to become a startup. Now, we knew that from the minute we met each other in Cambridge 9 years ago now. It's a long time. It was like, okay, you have that similar energy to me that I want to make a difference energy. It's you can feel it in certain people. You're like, oh, okay, can you hear that beeping? That's not a bomb. There's just a machine that needs some attention. Okay. Exactly.
That's Taylor Swift's fans. They've got a homing beacon on you now because we dared mention her name. I'm sorry. Apologize.
That's completely fine. I'm just going to warn you when it comes to pop culture references. I would just completely embarrass myself, I think, at this point. Really living up to that
Oh, me
PhD.
too.
Oh, great. Good to know.
A PhD in pop.
Yeah, exactly. Although I don't mind Taylor Swift. I will put that on record. Where
Okay,
was
there you
I?
go. Good. We need some positive things to
Well,
say.
I was talking
You said it was
about.
always going to be a startup, in
Oh,
your
yeah,
opinion.
of
It was just
course.
too obvious.
Yeah,
Yeah.
but it was the number of people in, like you were saying, in Silicon Valley who go there because they want to make a difference in some way, shape, or form. They want to make a new technology that revolutionizes some problem that we have. That I completely agree is palpable. You can feel it in the air. You go to a cafe and you'll hear the conversations about raising money, about how this idea could do this, how they've been talking to these people. Stanford, so many entrepreneurs and so many one thing my guilty pleasure, I mean, it's not really a guilty pleasure. One thing I love doing when I'm here is just going to talk to other startups about what they're doing and how they're doing it. Because there are, obviously, it was traditionally a scene for new tech development, new phones, new apps, new software. But now the climate tech scene has just exploded here. There are so many people doing technologies that could revolutionize or decarbonize a certain industry. There's green hydrogen startups all over the place. There are direct air capture startups, people pulling CO2 out of the sky, companies all over the place. And just being here, I was here for San Francisco Climate Week, and the number of interesting new ideas just blows me away. During that time, I'm obviously there to talk about Dioxycle. I'm there to talk about how we can make these affordable chemicals with a low carbon footprint. But I find myself accidentally talking to someone for like half an hour about how cool their technology is. And it's such a great place to be for that. I can't describe it enough. Obviously, Boston also has a big scene. New York has a big scene. There
It's
are
true. Boston,
hubs
yeah.
in Europe. They're all over the place. When you're in one, you can feel it. You can feel that everyone around is trying to make a difference, which is just motivating, inspiring.
Yeah, and you get a sense of that things are possible. It doesn't feel so out of reach. These things that feel so foreign to the individual person. We use all of these services, many of us dozens or even more. We use Spotify, we use Facebook, we use Google products, we use so many of these things, but they feel distant or almost alien, or like they have no bearing to the real world. It's hard for us to imagine, I think, Google as a physical place where human beings work. And when you see the size of the Google campus, you think, dear God, this is insane. But of course, you put two and two together and you realize it makes sense. Of course, Google would need a campus this big, which is truly the largest professional campus I've ever seen in my entire life. And of course, the Apple building in Cupertino, unbelievably cool. So many innovations. And you just get the sense that, yeah, it's possible. It's not just some pie in the sky dream. Like winning the lottery, it's much more to it than that. And I now see that for the very first time, and I don't think I ever did before, but I think that's really cool. So where do you spend most of your time then now, since you've traveled all over?
Most of the time I live in Paris. So about 3/4 of the year I'll be in Paris, and then 1/4 of the year I'll be here in the Bay, where we have a small lab. So we have our big lab in Paris that's focused on more of the engineering side, and we have a smaller lab here in the Bay, really working on the cutting edge research. And the two combined give us this nice complementary cycle of version 2.0 comes out in this Menlo Park lab, and then the Parisian lab will then work that into the larger product. I love it.
That's
I like
fantastic.
Europe. I like the Bay.
I love Europe.
But the only problem I have is my carbon footprint of flying back and forth. So my co-founder and I really try and obviously, number one, offset our emissions, but also make the trip worth it, make sure we justify that trip and stay here as long as possible. So we're trying very hard not to be hypocrites is what I'm trying to say.
Nice. Well, you could go Greta Thunberg and sail. You could always make the voyage with a boat.
Yeah,
I think it would take
do
you quite a while.
Cruise liner.
It's an option.
Unfortunately, I think if we took
yeah, cruises are really good.
2 weeks a year.
You want to talk about burning plastic and God knows what else.
No, yeah. Cruise liners are insanely polluting. We just don't think about it because it goes in the ocean. Sorry, that wasn't a question you asked at all.
They know that because as soon as you cross international waters. no.
I'm here to talk about cool technology, but don't get me started about cruise ships.
You don't get me started about cruise ships. That's bad. You have an ambitious plan. You believe that 800 million tons of emissions can be prevented. And you also think that Dioxycle can recycle 600 megatons of carbon dioxide per year. At least that's what's been stated. Do you feel that that goal is attainable, and how long do you think it's going to take to attain that?
The goal is definitely attainable. So that number is based on, number one, converting carbon from industrial sources of emission or from sources of CO2 that we currently have that aren't fossil-based, converting all those emissions into ethylene, whilst at the same time preventing the use of the steam cracker that I was talking about at the start of the podcast here. So
Still love that name.
me too. I mean, not so much actually from my side. I think it's an evil technology, but still, we're going to prevent that from being used, and that would lead to the mitigation of up to 750 million tons, or even more now that we look at the real emissions of that industry per year. The progress we're making to get there is rapid. So we're scaling up very, very quickly. It's one of the philosophies of the company, just basically to get stuff done. Let's get stuff done fast, as quickly as
We're
we
leaving
can.
in the original. Okay,
And
sure.
so we are
Great.
going as fast as we can to that target. We have to be realistic about our timelines. But ultimately, we say by 2050, if this technology continues to progress at the rate it is now, we do have that potential.
Brilliant. Well, I think it's absolutely fabulous as a concept. It is definitely a win-win. It's the type of solution that I think we're going to see more, at least I hope we're going to see more of these types of solutions in the coming years as we start to realize that the way we've always done things isn't necessarily the way that we have to do them in the future. But to reduce waste from industrial processes, to capture that waste, to turn it into something meaningful. There are so many parts of the chain that benefit from technology like yours. And again, we talk about win-win-win or triple bottom line, but this has the potential to be much more than that. 4 or 5 or 6 wins down the road, not the least of which is the degrading of plastic emitting further CO2 at the end of its life cycle, whenever that may be. So I, for one, am rooting for you. I think it's incredible. And when I see stuff like this, it does fill me with a sense of optimism to believe, what don't we know? And I think the creating of one thing from another thing, morphing something into another, seems to me to be the hallmark of this era that we're heading into, whether that be turning yeast into various things or turning byproducts into other things. It seems like we're entering an age where you can convert something into something else, which has only been the realm of science fiction for centuries. I can turn one bit of atoms into something else over here, and that I just find it profoundly exciting. Any advice, parting words to wrap it up for people who might be considering starting an eco startup, eco-tech?
Yeah, I mean, a lot. Basically, I have many little thoughts about, if we could start again, how we would have gone quicker, how we would have been more efficient. But ultimately, I would say the main advice people need to follow is get your tech right and get your team right. If you get a talented team and a good technology and just work at it, set goals and stick to them. I mean, for me, it's like one of those things where the answer is very obvious. If your technology, get your thermodynamics right, make sure the thermodynamics of your climate tech would ever make sense. Don't try and break any fundamental laws, and make sure you hire smart people with experience, or people who are not experienced but with endless energy and passion for a certain in a certain field or for a certain technology. Mix them all together and just keep working hard, and you'll start reaping the results. Let's say basically just work hard and stay focused.
Work hard, stay focused. Stay focused on what really matters and draw yourself towards the bigger problems that humanity is facing instead of the smaller problems that we all face day to day. That seems to me to be the moral. Well, I'm very glad that you've overcome your default state of pessimism for this venture. I'm glad that you've put it aside at least enough to build this new and exciting thing. I hope you reach your 2050 goal and, in fact, far exceed it. I think it would be better for all of us if you do. So thanks again for taking the time to share and geek out and talk with me about all of these interesting things. I find it profoundly fascinating. And for those listening, we've talked about Dioxycle a lot. That's Dioxycle. check them out. Check out the graphs, check out the website. Very cool website, by the way. Lots of mind-blowing stuff there that's really going to open your mind about what's possible and hopefully get you a little bit more optimistic about the future.
I should say the
So,
pessimism was just the pessimism that every British person is born with, and I'm overcoming that just through life experience. Thank you so much. Thank you for
you overcame that by going to Paris and the Silicon
There you
Valley.
go. America will really just pull pessimism out of you and throw it away. You leave that at the border.
Yeah, no more stiff upper lip for you.
Thank you so much.
Very good. Well, with that, the official podcast is over.